Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
Hello students, let us solve JEE Advanced Physics paper 2017 question number 2. Students, let us solve question number 2 of JEE Advanced Physics paper 2017. The question says a block of mass m has a circular cut, feet have frictionless surface. This is a block, as you can see here, is a block of which a section is cut of circular radius r. It is like this. This is having radius r. So this is r. Circular cut is made there. So obviously from here to here also it is r. This is a block whose mass is m. This is a block whose mass is m and having a circular cut at the edge. This block rests on this horizontal surface, frictionless surface. So there is a surface on which it is kept here. This is a frictionless, so I'll write μ0 of a fixed table. This is a table which is fixed, it's not going to move. It's a fixed table. Initially the right edge of the block is at x is 0. Right edge of the block is at x is 0. So this is the coordinate system at x is 0. In a coordinate system fixed to the table, a point mass m is released from rest at the topmost point of path. So there is a block over here of small mass small m, and it is released from here, so it will start sliding down. It will follow this path. So at the top of here I am just releasing the block and it slides down when the mass loses contact with the block. So the mass will come down and leave the surface at this point. At the time when it leaves the surface, its position is x. So if this is the coordinate system, then as this moves forward, as this block moves forward, this capital M will move backward direction. So this mass M will move forward and this capital mass M, that is the block, will move backward because the momentum has to remain the same. And the velocity is v. So the velocity of the mass while it leaves this point is v. At that instance, which of the following options is or are correct? So you need to find the options which are right. The position of point mass m is this. The velocity of the point mass m is this. So you have to find the velocity of the point mass. The x component of the displacement of the center of mass of the block m is this. The velocity of block m is this. So basically you have to find the four things: the position, the velocity and all. So let us first solve this question by how to find the position of the small mass m, or the velocity, or this or this. So when this is the diagram, this is the first diagram when the body is released, and as soon as at the end this is block displaces by x. Suppose that this moves by x, so then this diagram will become, I will draw like this. So let us suppose that this is the case when the block displaces, this block displaces towards left by x. This is x. This is also x, displaces by x. And at this time the mass, small mass is here. The small mass is here. It says that at the instant which of the following is are correct. So if I want to find the x value and see which one is matching the x component of displacement, that is x you have to find. So in both the cases, let us find x. To find x, I must write that if I choose this as the origin, then obviously everything is towards left, so finally the answer will be negative. So I'm just considering this as positive with no problem with that. We know that the center of mass question is that the center of mass XCM is m1 x1 plus m2 x2 divided by m1 plus m2. So, or I'll write that because there is no net external force, so the velocity of center of mass will be 0 and it is at rest. If the center of mass is at rest, then that XCM is fixed, means it will not move. The XCM, the center of mass of the system consisting of this small m and the capital M, the center of mass of this combination, wherever it might be, suppose it is here or there, that will not move. So if it is here, then it will be there only here. It will not change. But then these two individual masses are moving, their center of mass is changing. Here the center of mass of this block is here, small mass, and it is here. Now they are displaced. Initially it was here, now it is here. So this is the change in the center of mass of this individual particle. Similarly, suppose that the center of mass of this block is here, and earlier, now it is somewhere here, because this is moving by x, so there is a displacement of x. Here also there is a displacement of obviously x, because this moves by that distance. Now we have to find that if this is not going to change, this has to be 0, because the change of this XCM, as usual, the XCM is not going to change. XCM is not going to change. Now this combined center of mass XCM, from here this is XCM, and from this after displacement, that is also XCM. So this, suppose that this is here, so this is not going to change. If it is not changing, then the differentiation of this equation will give you 0. The differentiation will give you 0. So if I differentiate that, 0 will be m dx1 or m1 dx1 plus m2 dx2. That means I'm not taking the negative sign, I will put the negative sign afterwards. So what I have to say is that m1 dx1 must be equal to m2 dx2, that the displacement of first one the displacement of first one and the second one. So what is the displacement? The change in the positions, the first and the first mass and the second mass. These are the changes in the positions. So, or this is the change in the position vector. The position vector will change. The initial displacement and the final displacement, the change in the displacement of this particle. So if I see that, then if I think of m1 is the mass of this small one, and m2 I will consider the mass of the block. m1 I am considering for small m, and m2 I am considering for the capital M mass of the block. Then I will write that m1 dx1, m1 I write m. What is dx1? What is the displacement of this small mass? This was earlier here. Suppose this whatever is this value. Now it is here. So earlier it was at a distance r. You can see it was at a distance r. Now it is at a distance x. So r minus x is the change. So dx1 is r minus x. Because earlier it was at a distance r from the origin. Now because this moves, the block displaces the capital, the big one, the big mass moves by distance x. So the everything moves by distance x, and at the time the block reaches the edge, the displacement of the block is x. So the particle will be the mass m1, which I consider m, will be at a distance x from the origin. So now it is at x, earlier it was r, now it is at x, so the difference is r minus x. This m2 I'll write for the bigger block, capital M, and what is the displacement of that? Obviously, wherever was the position, now it displaces by x more, so there is a change in displacement of x. Suppose that it was at a distance of L, the center of mass was at a distance of L from the origin. Now it moves towards left by more distance x. So the new distance will be L plus x, and the final initial distance was L. So the change is x. So here I write that dx2 is x. If I solve this, I will get mr minus mx is capital M into x. So from here, if I solve this, then it is mr is mx plus small m into x. Just a rearrangement of this equation. This is brought to the right side of the equation, and this becomes this. From here, if I find x, x becomes mr divided by m plus m. So because it is shifting towards left, so I'll write x is a minus of mr divided by m plus m. So if I see the option, the x component of the displacement of center of mass of the block M is, because the block is moving towards left by x, so the x component, and obviously it has to be x component only, because the block is not moving in y direction, the block is only moving in this direction. So earlier it was here, now it is here, so the displacement is x towards the left of the origin. So this is the origin, so this is the displacement of the x component, displacement of center of mass of the block. Suppose it was here, now it is here, so same block. So the displacement of the center of mass of the block is x. This is correct. So if I see that option number 3, then it is correct. The x component of displacement of center mass of block M is this. The position of the point of mass M is x. the position of the point mass m is x is this. No, the position of point mass m is x. X comes out to be this, not this one. So that is not correct. So option number 1 is not correct. Not correct. Now, so what will the answer for this point mass position of the point mass m? The answer is this one only. This is the answer, not this one. And what about the second option? The velocity of the point mass m is. So what is the velocity of this point mass when it leaves the surface? So here suppose the velocity is v1, and we have to find that. By the time it leaves, it is having certain velocity, that is suppose v2. Initially its velocity is 0 and its velocity is 0. Now to solve for the velocity of this, I'll consider that the block is supposed to be here. The block is here living with the speed v1, and this mass capital M is moving with the velocity suppose v2. Now from because there is no external force, so in the absence of net external force, the momentum of the system will remain conserved. That means initially the momentum was 0, so the final momentum of this system consisting of these two particles will be 0. So that means the momentum mv1 must be equal to capital mv2. This is from law of conservation of momentum. So from here I can write v2 in terms of v1 or v1 in terms of v2. So this is one equation I have to remember. Then we'll proceed further. Now because we are interested in so this is also, if I want to write the velocity v1, then it is mv2 upon m. But then v2 is also unknown, so it is to find the velocity v2. So to find that, I have to use law of conservation of energy equation. And the law of conservation of energy is what the small mass which slides down, that lowers the potential energy, and the lower the potential energy. Now we have to apply law of conservation of energy. If I see the equation that the body has to slide down, so the decrease in the potential energy of the small mass m will be giving kinetic energy to the block capital M and the small mass m. So we have to, there is a drop of this height, that is by r, and this loss in potential energy due to this height h equals to r is giving kinetic energy to these two blocks. So therefore I write half of m1 v1 square, that is write m here, and half m v2 square equals to mgr. Here m1 is m, so write here half m v1 square plus now we are interested in the velocity of the small mass m which leaves the surface. That means we are interested in v1 and we don't want v2. So v2, earlier we got the expression last time that small m into v1 is capital M into v2. So from here v2 is mv1 divided by m, that I will substitute this value over here. When I substitute this value over here, I'll get half mv1 square plus v2 square is this square of this, square of this, and this is mgr. So from here I will cancel this capital M1 and the small m here, here and here. So this is left with, I'll use as a pen, this is v1 square by 2 plus this is m upon m, 2 here and v1 square there equals to g of r. So if I take common v1 square by 2, this will become 1 plus m over m. This is gr. If I write then once more, this is v1 square is 2gr, the other side of the equation, divided by 1 plus small m over capital M. So v1 comes out to be under root of 2gr divided by 1 plus m by m. So in the question it is given that the velocity of the block v1 is considered as small v. So I'll write that the small v equals to 2gr over 1 plus m by m, the root. So the velocity of the point mass is this, and our answer is also this. So therefore this option is correct. The velocity of the block M is this one. So what is the velocity of the block M? Let us find the velocity of the block M, if it is matching with that or not matching. What is given is that the velocity of the block capital M is minus m over m to gr. Minus sign indicates that this block was moving toward this side, so it is therefore minus. But then magnitude we have to check it, because we have the relation m of v1 equals to capital M of v2. This we have considered as v, small v, and this we have considered as capital V. So capital V equals to small mv divided by m. That means m over m. And v, that last time we got, it was 2gr divided by 1 plus m over m under root. So if I solve this, obviously if you want to give negative sign you can give, but it's okay, then I'm giving you a negative sign because just the velocity is opposite to that of the other. So this is minus m over m. If I solve this, then this becomes m plus m over m. So finally we have to see whether this is matching with this. I don't think in any way this will match with this, because to match this with this has to be 1, this has to be 0, then only this will match, and this can never be 0. So therefore this is the actual answer for this velocity of the block, capital block, not this one. So this option is wrong, it's not correct, this is wrong. So this is the right answer, but this is not given, so therefore I don't have to write this much, 2gr 1 plus m over m root. So what I want to say is that in the question, if you see the option, this is the velocity of this block M. No, this is not the velocity. In fact, this is the velocity of this capital mass. So therefore, the answer to this question number 2 is 2 and 3. Okay, thank you.